This video is going to be on oxidative hemolytic anemia, meaning that the red blood cells are being oxidatively damaged by some sort of toxin and causing red cell lysis. So some things that can cause oxidative hemolytic anemia include ingestion of large amounts of onions, garlic, cabbage, or kale. And in horses, ingestion of red maple leaves or red maple branches can cause this. Some drugs can do this as well, especially Tylenol or acetaminophen in dogs and cats, propylene glycol in cats, zinc in small animals, and copper in sheep. Propylene glycol is a preservative used in some foods, and it's also used as an antifreeze. Zinc can be found in various metal objects, especially pennies. And copper in small ruminants, specifically, the copper can build up in the liver, and under some stressful event, the massive amount of copper is released and can cause an oxidative hemolysis. Okay, so let's look at the blood smear findings that we look for to identify an oxidative hemolytic anemia. The first is Heinz bodies. Heinz bodies are essentially this nose pointing out from the side of the cell, or if the nose is pointing out at you, it might look like a pale circle. In either case, Heinz bodies are denatured hemoglobin, so globin that is aggregating together and binding to the inside of the membrane. Now, Heinz bodies can normally be found in cats, so 10% or less of red blood cells in cats can normally have Heinz bodies, and you can have Heinz bodies, increased numbers of Heinz bodies in cats without toxic oxidative hemolysis. So cats with diabetes mellitus, hepatic lipidosis, which is an accumulation of lipid in the liver, or hyperthyroidism, those diseases, you can see increased numbers of Heinz bodies, and it doesn't necessarily mean that there's a toxic oxidative hemolytic event. So the other thing that you look for on a blood smear is eccentrocytes. This is when the membrane of the red blood cell is oxidatively damaged and the membrane fuses together, and it pushes all of the cytoplasm to one side. If you were to look at a cross-section of this red blood cell and turn it 90 degrees, you would again see that fused membrane on the right side, and then all the cytoplasm is pushed to the left. Now, oxidative hemolysis results in intravascular and extravascular hemolysis. If there's a big intravascular component, then you can see ghost cells, and you can particularly see Heinz bodies within the ghost cells. Another thing you can see with oxidative hemolytic anemia is something called methemoglobinemia. That's when the iron itself has been oxidatively injured and changed into its ferric or 3+ form. And this actually changes the color of the blood from a bright red to a chocolate brown color. Also, grossly, you would look for the exact same things that you would look for with an immune-mediated or infectious hemolytic anemia. So icterus, hyperbilirubinemia, bilirubinuria, hemolysis, and hemoglobinuria, those are all can be seen with oxidative hemolytic anemia as well. So that's it for oxidative hemolytic anemia. We've gone through the common toxicants, the two morphologies that you look at for a blood smear, Heinz bodies and eccentrocytes, and grossly, you can look at a chocolate brown discoloration of the blood sample.